Hi, today we'll start the next installment of the programming patterns. And we'll start learning about 2D DP, but I want to start it off with an easier video. And we're mainly going to talk about walking through a 2D grid. And as you know, the kind of shape of the DP, array or matrix is dependent on how many variables we're kind of saving in or tabulating, right? Um, and so if you just think about a grid, it naturally lends itself to like a two-dimensional because you have, your X and Y axis. And so we'll start from here, which I believe is a very easy entry point. And this will be a shorter video, mainly because, as you can see, you can very easily get the gist of what I'm trying to do here. And there's a bunch of related problems I want to just show, just to show how, just learning a little bit would very easily expand your knowledge. And here I'm actually going to show my implementation for the first two problems. But for the last three, I'm going to challenge you to do them by yourself. After like, pausing for 5 seconds, then I will give a little hint. But then after that, you can, you know, if you're still struggling, you can just look it up online. But you should be able to do these problems after just going through the first two. Again, you'll see that it's again the 2D nature of these problems, like the grid nature makes it very easy to see what the transitions are. And so let's start out with unique paths. I've covered this in a previous video, I'm pretty sure. And like the combinatorics solution also works. So the gist of it is when let's pick a random cell in this grid. So I don't know, let's say we're looking at this one. And so this restriction of moving either down or right means that in order to reach this cell, what are the cells we have to visit first, right? Because we can't just directly go from the starting point to here. Well, there's two places we can come from because we can move left or sorry, we can move either down or right. So it must have come from a cell that's either to the left of it or to on top of it. And those are the only two ways you can reach that cell. And this actually applies to all the cells, right? So if we're talking about our goal cell here, we can only reach the goal by either going from the top or from the left. Well, this is basically saying I have these two possible places I can go to the goal. Well, how many ways? I don't know. Let's call this X ways to reach the top one and Y ways to reach the bottom one. So the goal number would just be the ways to reach X plus the ways to reach Y. Since we know we can reach X in, however many different ways, we can reach Y, this cell here, in Y different ways. And so we can reach G from either one of these, so it'll just be additive. And so you can just start building your DP from there. Initially, we start here at the start, the top left, and we have one way to reach that because, we're already there. And so if we think about building this array, you have to watch out for edge cases on these edges such that, you don't go out of bounds. So for this, it's pretty easy because it just looks at the previous one. Remember, we're looking at the left or the top. So it's just basically the sum of that. And the same here, which makes sense if you think about it, right? Because in order to stay on the edge, you have to keep moving, either keep moving right or keep moving down. And there's only one possible way you can keep moving right, or one possible way you can keep moving down. So once we reach this cell here, we have two ways, which is the number of ways reaching from here to the number of ways reaching here. Again, it's just additive. So this comes to 2. And we can build this array. This time for this cell, we know that this comes from here or here. So we know there's one way to get to here. There's two ways to get to here. That means there's a total of 3 ways. and we can just build the array up until we reach the very end. All right, so implementation is well, it's fairly easy. Well, let's take a quick look here. Yeah, so you instantiate your grid. I instantiated them all to ones just because the starting space is one, but it doesn't really matter. You can instantiate them to 0 as long as you keep the starting space to 1, and then just sort of iterate through. And then the array is just going, or I instantiated the one also to take care of the first row and the first column. So I can start from 1 to n and 1 to m here. And it's essentially, like I mentioned before, it's just the summation. And then in the end, you return the answer, which is the last one. Okay, cool. Now we'll move on to the minimum path sum. As you can see here, I'm already repeating myself a little bit. So for this problem, it's essentially the same, except you just have to watch out for a few additional factors. So in this problem, you are also moving from either the top, move down or right. Okay, so you already see a pattern here. So in order to reach the goal node here, you either move from this node up here or this node up here. And so how do you calculate the path sum? Well, you just kind of add it up, right? So the starting value stays the same because we start there, and we don't move there from any place. So this stays at 1. 3, we can either go from the top, which is non-existent, or from the left. So you can treat the values out of bounds here as like just positive infinity. All of these are positive infinity. If we think about it that way, then we can say it's the minimum of either going from the left or from the top. And so if you think about going from 5 here, okay, so let's change this to a 4, right? Because we can only get there from taking 1 right from the starting point and change this to 2 with the same logic. So what about this 5? Well, we can spend 4 getting to the top, right? Or we can just spend 2 getting from the left. So in this case, we want the smaller value, which means we want to take the 2, and remember we have to add it to the 5, so this now becomes 7. And so you can see a very clear pattern of how this is very similar to what this old solution, and then eventually you just keep moving until you reach the bottom right. All right. And here I'm just going to show a quick implementation. Anyway, yep, so you come from here, you basically check the minimum of either the top or the left, and then you return the end. Yeah, so again, if we compare these two codes, like you can see they are very similar. The main difference here is that you have an extra minimum here, while this is just additive. So it's just a little bit more work here, but in the end, it's very similar. All right, that's the end of the like lecture-ish problems. So here I would encourage you to try this out on your own. The minimum falling path sum. So here, where I'm gonna shut up for a second, and okay, so hopefully that was enough time for you to pause or the video. And now I'm going to go ahead and talk about like a hint if you still haven't gotten here. So last chance, pause the video. Anyway, so here, all you have to do is to basically modify the function from before so that instead of going from top right, you have to just go, there's three possible places to come from. Like it says here, it could be directly top or diagonally either way. So let's say you're at 5, you can come from 2, 1, or 3, and obviously you want to take the minimum of that. So you want to choose the 1. And then you just keep going until you reach the bottom row. And another big thing here is that there's no set goal, right? The set goal is just the bottom row. So once you reach the bottom row, you want to take the minimum of all of them. Yeah. So actually, there is something I just a small thing I wanted to mention. Like something like this solution, when I'm modifying the grid directly, Python is passed by object reference, which means if you're passing an array here, the original array would get changed. And so if you're in an interview, make sure to ask the question of whether you can reuse it. If not, and you would just make a copy of it first and operate on that copy, right? Instead of modifying the original. And so that's one thing that I forgot to mention before. But anyway, yeah. So if you are still not struggling after the hint, you can go look it up. Maybe if it's a popular subject, I'll cover it in another video. Yeah. So here's another one that you should try for yourself. Actually, I want to put this one first. So here, another thing I want to try for yourself. Very similar to this one, right? You can already see that these are all very, very similar. And so here, I'm gonna give again a few seconds to pause. And now, if you still need a hint, like here, you know that it's just the different way you can fall. So if we encode it so that, remember, this is 0, this is 0, 1, this is 0, 1, 2. So if we think about this 5, right? Which ones can go to 5? Well, 3 and 4, right? In this case, which are in the previous row, index 0 and index 1. And 5 is at index 1 in its row. So what do you notice from that? Well, let's say you can get to 5 by either taking the index of the previous row at the same spot or the index -1 of the previous row. And of course, you have to check for out of bounds. So if we look at it again from here, we know that 8 is index 2 in the last row. And so the ways you can reach 8 are 5 and 7, which are index 1 and index 2 of the previous row. So that's how you can do the transition there. And at the very end, remember that it's still just looking for the top to bottom. So you just have to, at the end, for the result, you just have to take the minimum out of the bottom row. All right, so move on to unique paths 2. This is, again, very similar. And I'll give you some time to pause here. All right, if you still haven't gotten the solution yet, I will essentially, you can treat these blocks as infinite. I think I kind of gave it away before, but just like how you can treat the out of bounds as infinite, you can treat obstacles as infinite because you can't get to that obstacle. And so, if the end result is infinite, that means you can't reach it. So for example, if both of these were blocked, then you would take the minimum of infinity and infinity, which goes to infinity. So you have to check at the end. If it is infinity, then, it's not possible. Otherwise, you would go, or it would be, the answer would be 0. The number of paths would be 0. But again, yeah, the main idea here is you can treat this as infinite. All right, so hopefully those weren't as hard for you. They were very easy, kind of an extension of the two problems I mentioned in the first part of this video. But here's a challenge one for anyone trying to seek a little bit more. So here's the dungeon game. Again, I'll give you a couple seconds to pause the video. All right, so if you're back, I'm assuming that you're still trying to figure this out, or but I think the one big hint is to think about it, because we've been talking about it from top left to bottom right. And so one big hint here is to think about it from the other way around. So if we were to start at -5, if we were to start at the goal here, we know that we have to have, if we chose the top path, again, you can only come from the top or the left, right? If we chose the top path, then we can get away with having 5 health, right? Because if we ignore everything else and we're just focusing on the 1 and -5, we can pick up the 1, which would give us 6 health, and then go to -5, which would bring us to 1, right? So that would make us survive. However, if we came from the 30 path, right, we would be able to get survive with 1 health, because we would have 1 health going to 30, which would boost up to 31, and then going to -5. And so remember, we have to always start with 1 health. And so do that and see if you can get anything. And once you've calculated it all, remember that since we're starting from the back and going to the top left, your answer is going to be at 0, 0, and not at the -1, -1. Yeah, that's all I have to say. Hope it was somewhat informative. Another thing, again, emphasis on, if we're talking about a real interview here, then you want to make sure to ask the interviewer whether this should be modified, because if it's not, you can technically get away with, of 1 extra space. But if it has to be, has to preserve the original grid, then you have no choice but to sort of use another, or I say have no choice, but you can actually make the bottom up more efficient memory wise. But my case is, always try to, reuse this if possible. But if the interviewer says no, then you're not. Yeah, that would be about it. I hope this was somewhat informative. This is more for the beginners. I realized my first video might not have been that friendly to beginners, and so we'll start talking about a more complex techniques later on after we've built the foundation. So the one video after this, I'm thinking of doing some binary search problems because it really opened my eyes up on like what sorts of things it can do that I'd never really thought about before. And so that's all from me today. I hope you had a good time, and I will see you in the next one.